So here we're going to find a confidence interval for a data set. And we can do this in a couple of different ways in StatKey or a spreadsheet. I'm going to start off with the spreadsheet and then check it in StatKey. So I'm interested in finding the mean water temperature of a river during the spring runoff from nearby mountains. We must estimate the mean temperature in degrees Celsius with the following sample data. So keep in mind, the river's flowing along and it's wide and it's deep in some parts and shallow on the other. Temperature is going to vary in different spots of the river a little bit. It's going to vary at day, it's going to vary at night. And so here I have some random sample of temperatures in a certain region of a river. And we want to use this to say, okay, on average, around now, we think the average temperature of the river is about whatever. So according to this sample, I've already calculated from the 30 sample temperatures above, the average temperature was 8.667 degrees Celsius. So based on this sample data, I would say to someone, well, based on the samples I took, I think around now the average temperature is around 8.667 degrees Celsius. Is that the exact temperature? Well, I don't know. I didn't test every single spot in the river, and it varies day and night. So I want an interval to expand that and a margin of error to go with it. So let's go about doing that. Since I provide the sample statistics here, we could just plug those into a spreadsheet, or we could use one of the spreadsheet tabs that takes the raw data and recalculates those numbers. So I'm going to do that version there. I'm going to take that data, copy it, go over to that spreadsheet we've been using, and find the right tab. All right, so let's think about the tab we need here. We're doing a confidence interval for a mean, so I just need to find a tab that says confidence interval for a mean. All right, so third one here, CI mean. Okay, so this one requires the summary statistics, not the actual data. So I could use the summary statistics given, but I want to use the data. Oh, here we go, CI mean with data. So I do have one there. And confidence interval, a bunch of numbers. So I'm just going to reuse it. So again, when I reuse one of my spreadsheets here, I often duplicate it in case I need the one I had. So this would be CI mean. Give it some kind of name that you can find the right tab again if you need it. And then the given information, especially a list of numbers like that, they're not going to be the same size. Delete whatever's there, and then paste your stuff in. So these are river temps, and usually I set it up so that the first cell is the title of the data, and then paste the data after, and hopefully I get the same numbers that that problem said. 30 temperatures, yep. X bar, let's blow this up a little so you guys can see better. 8.66666, okay, so 8.667 I think is what my problem had said, yeah. And standard deviation of about 2.37, yeah. So that matches what I pre-calculated for you here in the problem. All right, so now we're ready to do the confidence interval. And the spreadsheet is designed to do that, provided I have the right confidence level. My problem said to use a 95% confidence level, check, got it. And then the computer automatically calculates for me the spreadsheet, the magic t-score, sorry, spreadsheet, the standard error, the magic t-score, the book calls t-star, the margin of error, the lower and the upper. So, okay, so here's a surprise question for you. Which number on my screen here would I call the point estimate? Anybody remember that?
The X bar.
Mm-hmm. Yeah, the point estimate for a confidence interval is always the sample mean or the sample proportion. So this X bar right here, that's what I call the point estimate. Also referred to as the sample statistic. There's a bunch of sample statistics here, by the way. 30 is a sample statistic, it's the sample size. 2.37 is a sample statistic, it's the standard deviation of the sample. But the most important one for me here is really the middle of my confidence interval, and that's that number. So point estimate is also the sample statistic. Cool, good job. All right, so there's my confidence interval, and this problem just wanted to know what was the confidence interval. I also have a margin of error here, and I'm going to state an interpretation for this too, because that is something we need to practice on. So let's split the screen here. see how this problem wants it. So there's multiple ways to enter a confidence interval in reality, in a computer, whatever. So I just want to summarize that in my notes right here. Page. Often the confidence interval is shown as a mathematical interval where we use a parentheses, we state the lower number, and then comma, we state the upper number of the interval. Sometimes, however, we state the point estimate, whatever that happens to be, plus or minus the margin of errors. That'd be another way to talk about it. And when you read literature where they're trying to estimate what's going on with a population, often what they'll do is they'll state the point estimate, and sometimes next to it in parentheses, they'll put the margin of error. Once in a while, depending on whether it was designed for being read by people that are in that same field, or whether it's designed to be in some newspaper or magazine, they might do the interpretation instead, where they talk about in words the upper and the lower. But for the math problems we have to do, either it's going to be in this interval form, or it's going to be the point plus or minus the margin of error form. So for this one, our problem was asked for this version right here, the interval form. So, and then accurate to 1 decimal, no, read the directions, Gary. Accurate to 2 decimal places because the sample data are reported accurate to 1 decimal place. And often in statistics, when we do summary statistics, the final answers, we take out 1 more place than the data in the end. And this is the end. So lower is 7.78. Upper is 9.55 from my data. And it's bugging me along the way, right? If I didn't finish the parentheses, it says, well, it's not giving me the error now. Huh, it was there a minute ago. It said, hey, that's not interval notation. And yay, I got it right. All right, and then here, again, it's bugging me down here for interval notation. So usually I try to put prompts in a couple of different places for these problems. Sometimes it's only in one spot, but definitely look at the fine print. And on an exam, if you used a spreadsheet to do this, make sure you send me the spreadsheet right after, so that if something goes wrong here, I can look back there, or in your written work, take a picture of it and send it to me. Very important. All right, so I want to see if StatKey agrees with this confidence interval by running a randomization confidence interval, and then I'll write the interpretation. So to use StatKey, we need the raw data for a mean, which means I need all that original data there. And then I just got to go find the right spot in StatKey. So I'm just doing this as a backup, kind of check my work. Am I on the right track here? So what are we doing here? We are doing a confidence interval. And this is a single mean, so that's up here. Not a difference in means, a single mean. I only have 1 population, that 1 river. And then I want to edit my data, delete everything, and then paste my stuff in. And then I got to double check these check boxes. I don't have a first column saying, what 6.6, came from spot A and 13.6 came from spot B or something like that. And I also deleted the header row. So I'm going to get rid of that checkbox. And OK. So I should find that I have the right sample size, mean, and standard deviation, which I do. So I'm ready to generate thousands of samples. And then confidence interval is always 2 tails. And then I want to make sure I have the right confidence level in the middle here. And StatKey says, based on this randomization, it thinks the interval should be somewhere between 7.83 and 9.533. Are those exactly the same numbers I found? The answer is no, but they're close. They're in the ballpark there. And if I rerun this, it's going to give me a slightly different set of numbers there. So if I reset it and generate another 6, 7, 8,000 samples of this original 30, so I don't have a new sample size. Each one of these dots here is another sample of size 30, but based on those numbers there. And this time I get 7.84, 9.533, 0.537, so it's around the same as what Stackey thought it was before, and it's not too far off from what the central limit theorem thought. Will there be a difference between what the central limit theorem says and what the randomization says? And the answer is yes. My sample size is exactly 30, which is the threshold of where the central limit theorem starts to kick in. So I should expect some differences between the randomization version from Stackey and the numbers I got here from the central limit theorem. But they're similar, so I feel confident that I've got some good answers here. Next, interpretation. What do these numbers mean? So then we have to think about what is the variable. So the variable I'm trying to estimate is the average river temperature, spring runoff time. So I would say something like, we are 95% confident that the average river temperature during the spring runoff is between, and let's see what my numbers again, 7.78, 9.55. Boom, done. Somewhere in that interval is what the river should be for the average temperature in the river. All right, and time is spare.